Hello, and welcome to today's webinar, Moving Towards Solutions, Partnering with Communities to Make Homes Healthier. I am Dr. Barbara Malkus, Board President of Massachusetts Breast Cancer Coalition, and I'd like to thank you all for joining us today. Massachusetts Breast Cancer Coalition is dedicated to preventing environmental causes of breast cancer through community education, research advocacy, and changes to public policy. I am pleased to welcome today's speaker, Dr. Robin Dodson. Dr. Robin Dodson is Associate Director of Research Operations at Silent Spring Institute and a research scientist with expertise in exposure assessment, particularly in the indoor environment. Dr. Dodson is an adjunct assistant professor of environmental health at Boston University School of Public Health and also holds an appointment as a visiting scientist at Harvard T.H. School of Public Health. Dr. Dodson, welcome to today's webinar.
Thank you for having me. It's a pleasure to be here. I'll go ahead and start my presentation. Okay. Well, welcome everyone. Thank you for being here, and thank you to MBCC for providing the opportunity to share some of our research today. I am Robin Dodson. I am a scientist at Silent Spring Institute. I've been there for over 17 years now, and a lot of my research focuses on thinking about our exposures inside of our homes, the place where we spend a lot of our time, or most of our time, right? So first, before we jump in, I want to kind of pause and have everyone kind of reflect on, when I ask the question, what is pollution? What are you thinking about? Are you thinking about perhaps the smokestack outdoors that you see kind of at distance? Are you thinking about a contaminated water stream or a lake, or something else that's kind of happening in the outdoor environment? Well, what I would like to kind of share for this presentation and kind of refocus some of our attention is actually, when we think about pollution, the ambient pollution or the outdoor pollution is very important. However, there are a lot of kind of much more personal or intimate pollution sources in our everyday lives. So you may not realize that indoor air pollution actually tends to be much higher than outdoor air pollution. And that's a result of the furnishings inside of our homes or the products we use inside of our homes. Think also about how we have an interaction with the things in our homes. We might lie on the couch with our dogs. We might just have a much more kind of intimate or close contact with those pollution sources inside of our homes. Of course, we can also introduce pollution into our everyday lives through the food that we eat and bring into the house and our general behaviors inside the house. So my focus today is to share with you about how to focus on an area or a place that we spend a lot of time, and that's right inside of our homes. And that's where a lot of our research has been spent in the last several years at Silent Spring. So when thinking about indoors and thinking about indoor exposures to chemicals, there's this really great kind of thinking piece or framework that came out now, well over a decade ago. But this idea of moving environmental justice indoors, right? When we think about environmental justice and we think about pollution, again, it's kind of out there, outdoors. But a lot of the work that we've been focusing on is bringing that indoors. And the reason we think of this as kind of an environmental justice issues or reasons for wanting to focus on the indoor environment is because our exposures in the indoor environment are a function of the sources inside of our homes. So that can be anything from the cleaning products we use, the furnishings we use. Of course, there can be pollutants coming from the outdoor environment. So those sources are in the home, and then we can be exposed in a variety of different ways, and it's modified depending on our ventilation system inside of our home, depending on our activities or our behaviors inside of our homes. And so it's with this framework, this idea of it's a function of what's in our house and how we behave in our house is where a lot of our research has been focused, so that we can try to identify some solutions or some effective strategies. So want to kind of pause for a moment and talk a little bit more about the chemicals that we're most interested in when we're thinking about indoor chemical exposures. A lot of these chemicals are a function of the consumer products that we use inside of our house. So we call them consumer product chemicals. And when I'm talking about consumer products here, I'm talking very broadly. I'm talking about furnishings, so like our couches. I'm talking about soaps, lotions, more personal care products. It can also be in how we furnish our home. It can be the materials that we use in our home. So I'm thinking a very broad definition here. But when we think about these chemicals, they are quite ubiquitous in our everyday lives. I'm talking about things like phthalates. Phthalates are used as plasticizers. They're also used in personal care products. Things like parabens, which can be used in personal care products as preservatives. They can be found in foods. We have the bisphenols, so BPA you might be familiar with. We talk about UV filters, both those UV filters that might be added to the personal care products that we use. We also know that UV filters are often added to things like paints so that the paints last longer. Of course, antimicrobials and flame retardants. So flame retardants are things that are intentionally added, or chemicals intentionally added to products inside of our home. PFAS, which we've all heard a lot about, those are those forever chemicals. There are sources of those chemicals inside of our home, and of course, fragrance chemicals. And all of these, right, you look kind of to the right, showing you photos of things that you encounter in your everyday life in the indoor environment, in your home environment. So we know that these chemical sources are ubiquitous, and that they're commonly found in the indoor environment. And this is actually a kind of a schematic or a figure that came out of a National Academy's report about 2 years ago. And this National Academy's report was looking at the indoor chemistry and why it matters, in particular focus on thinking about inside our house. So oftentimes when these chemicals might be released from a product, they can redistribute throughout our indoor space. That's because they're considered to be what are known as semi-volatile organic compounds. They're semi-volatile, meaning they're sometimes in the air that we breathe, but they can also be found on surfaces. They can be found in the dust inside of our house. They can be on our skin. And so they're all kind of constantly redistributing inside the indoor environment, which is kind of fascinating to try to study and understand, but also makes things really complicated when you're an exposure scientist like me, who's just trying to understand how are we exposed and to what amount are we exposed to these chemicals. It also means that we can look in a variety of different ways, or kind of start our investigation of home-based exposures using a variety of different, looking in a variety of different places, right? We could measure indoor air, we could collect house dust, for example. And we've been doing just that at Silent Spring Institute. In fact, we started this over 25 years ago with our Cape Cod household exposure study, where we were actually the first to measure many of these chemicals inside US homes. This study involved 120 homes on Cape Cod, and we looked for 89 chemicals, most of which are considered to be endocrine disrupting chemicals. The reason we were focusing on endocrine disrupting chemicals is that we're very interested in thinking about exposures to chemicals that might be plausibly linked to breast cancer. So we know that if you take a breast cancer cell in the lab and you were to add things that add estrogen, it will grow. And so any chemical that might act in a similar way, that might alter our estrogen system or our progesterone system in our bodies, could have an impact on our breast cancer risk. So we were focused on trying to understand where and how are we exposed to these endocrine disrupting chemicals. And so that was our first study on Cape Cod. We measured indoor air, we measured house dust, looking for these 89 different chemicals, and we also collected urine samples from our participants. And that was just the beginning. In fact, we've since have gone into Northern California, looking at environmental justice community, again, looking at indoor air and house dust, also coupling that with outdoor air so we could look at the industrial sources or the contribution of industrial sources. We've extended that work into low-income housing in the Boston area, also on college campuses. We've been in subsidized housing, HUD subsidized housing in Boston, Cincinnati, and New Orleans. We keep going. We're now wrapping up a study in Rochester, New York, where we're looking at households with children living with lead hazards. Again, collecting things like house dust. And have more recently focused on looking at PFAS impacted communities and looking at the potential residential sources of PFAS in those environments, in our home environments. So we have been studying the indoor space for these endocrine disrupting chemicals for well over 2 decades. To try to understand where are these chemicals coming from, and then really with the idea is trying to understand, can we develop effective strategies or interventions to help mitigate our exposures to these important chemicals. So what are we finding in all of these studies? We know that these consumer product chemicals are in our homes because we can measure them in our dust. And actually, this is part of what we call a meta-analysis that I was part of a couple of years ago now. But what we did is we looked across the research, including ours at Silent Spring, to try to understand what kind of chemicals are we finding in house dust and at what levels. And when we did this kind of broad look across dust studies, we found that phthalates, so things like DEHP, which is found in vinyl products, and it's been associated with altered reproductive development, particularly in boys, for example, is found in 100% of homes. In fact, every single home that I have gone into, I can measure phthalates. They are truly ubiquitous. We're also finding other chemicals like fragrances. So HHCB is synthetic fragrance. In the red there, we can see a couple of flame retardant chemicals. The TDCIPP, that flame retardant, is associated with cancer and can be added to things like furniture inside of homes, and also parabens. So when they are added as preservatives into personal care products, parabens don't stay put. They get released into the indoor space, and we can measure them, in this case, in the house dust. So what are we seeing in terms of levels? This is actually just kind of showing what's called the pool geometric mean, or our kind of best estimate of the levels in homes. And the reason to show this is twofold. One is that there are a lot of different chemicals, right? We're only showing really, a small fraction of the number of chemicals that we can measure in dust here. You can see that the phthalates there in blue tend to be found at higher levels than, say, the PFAS over there in purple. But that is not to say anything about their potential health risks. Rather, that's just the level that we find them in. The other thing I want to note is that we're finding these chemicals in orders of magnitude in terms of concentrations, right? So 4 orders of magnitude here, actually. And that's really important. There's a lot of variability when we're looking at these chemicals in our house dust. So these chemicals are in our dust. They're also in our indoor air. This is data coming from our green housing study. So that's the subsidized housing in Boston, Cincinnati, and New Orleans. And what I'm showing here are measured indoor air concentrations in homes. These are actually homes, subsidized housing units in which asthmatic children were living, for different consumer product chemicals. We've got phthalates, parabens, and triclosan. Triclosan is an antimicrobial, was more commonly added to things like soaps. And so what I'm showing here are the measured concentrations, and also want to kind of reinforce here the variability over which we're seeing these concentrations. So for example, if you look at the very bottom there, we have DEP, that's diethyl phthalate. It is a phthalate that's commonly associated with fragrances or fragranced products. You can see that we're measuring that chemical across orders of magnitude. So all those black dots kind of have a big span. And what's important is that that is actually kind of the start of where we begin when we're trying to understand what's going on inside of homes. Why do some homes have much higher levels than others? And that starts us asking a kind of a query or a kind of line of questions around what's going on in those homes so that we can figure out what the sources are and start developing effective strategies to try to limit our exposures. So this variability that we're seeing is just the beginning. It's the kind of the launching off point for a lot of the work that we've done on trying to identify sources and then identifying effective intervention strategies. Another way that we have started to try to identify intervention strategies is based on results from a study that we call the move-in study. So this is a study of homes, specifically I should say subsidized housing development in Boston. This housing development had undergone some recent renovations. And so we sought to look at exposures or levels of these important endocrine disrupting chemicals inside of homes before and after residents moved in. The reason for this is that most of our work, right, is that we go in and we collect a house dust sample. So that means I'm actually going in and I'm vacuuming in people's homes, or I set up an air sampler in somebody's home. But we're doing it while they're there. Maybe they've lived there for a really long time. So it's really hard. It can be very hard to disaggregate those sources to try to understand, well, is it because of what we built the house with, or is it because of the behaviors of the participant, of the person inside? So with this move-in study, we sought to try to pull that apart a little bit. And so by measuring both pre-occupancy and then post-occupancy, we can try to then attribute what are the chemicals that we're seeing because of the resident when they moved in versus what was already there as a result and is there because of the way that the homes are built. So what are we seeing? First, I'm going to talk about those chemicals that are influenced by the building. These are really important to understand because we might want to then say target any intervention strategy around the building materials. Maybe it's about paints. Maybe we could work with contractors about the practices that they employ as they are inside of homes. We could talk to certification programs, right? This housing development actually met a lead or a U.S. Green Building Council's green housing certification. So if we work perhaps with the certification programs, that could be a way that we address some of these exposures. So what I'm showing here are chemicals for which the levels tended to be higher right after the renovations were complete, and they tended to go down over time, even once somebody moved in. So we've got the pre, so that's before people moved in, and the post for each of these chemicals. And so what are we seeing here? Well, here are two examples. These are actually VOCs, so things that tend to be in the air. Toluene and xylene, you can see went down with occupancy. These are very common in solvents that are used in renovations or in buildings. So we're not surprised by that. One, though, we're kind of surprised about was this chemical, BP, or benzophenone. Benzophenone is a UV filter. It can be found in your personal care products. I think what's happening here is it was added to the paints, right, to make the colors last longer so they don't fade in sunlight. And we can see that benzophenone, a UV filter, is a result of the building materials or the way that we handled the renovations in these units. Two flame retardants that we're also seeing as being influenced by the building itself are TCIPP and TDCIPP. I mentioned TDCIPP before because this chemical has been associated with cancer, and you can see that the levels are going down. It's likely that these chemicals are being used as flame retardants in things like insulation. And so as part of the renovation, they re-insulated many of these units. So those are the chemicals that we might want to say, let's work with the folks, the managers, the contractors, even the architects when we're thinking about developing effective strategies for limiting our exposures. Now, of course, there's also chemicals that actually went up with occupancy. So these are chemicals that we said are associated with occupancy. And so our focus might be a little bit different. It now is focused on things like how can we do education with occupant education to help them help occupants understand the influence of their behaviors or the products that they bring into their home. So calling out a couple examples here. First of all, those chemicals that were only detected once people moved in. Things like methylene chloride. Methylene chloride is a very toxic solvent, typically used in paint strippers. Thankfully, there's been some more work recently on trying to restrict or ban this chemical in some kind of consumer products that we might encounter. Things like perchloroethylene as well only came in with occupancy. Again, it's a solvent, historically had been used for dry cleaning. Not surprisingly, two synthetic fragrances, AHTN and HHCB, both of these are weakly estrogenic, so they act like estrogen in our body, tended to go up during occupancy. Kind of makes sense, right? That folks are using fragrance products when they come in. Triclosan went up with occupancy. This, I kind of wasn't sure where this would land. Triclosan can be used in building materials. So when you see things that are, even like counter surfaces, sometimes you see kitchen tools that all say that they're antibacterial or antimicrobial. That can be triclosan. Triclosan is a thyroid disruptor. And so it's altering our thyroid system, which is very important in our bodies. In this case, though, I think triclosan was being introduced by occupants through the products that they were using. Until about 4 or 5 years ago, triclosan was very commonly used in both hand soap and in toothpaste. The FDA has actually banned triclosan in hand soaps for consumers because it wasn't shown to be any more effective. And that actually is kind of a clear takeaway from some of the work by the FDA, is that regular hand washing with soap and water is just as effective as buying those fancy antibacterial hand soaps. So let's keep those for particular situations, like hospital settings and things like that. Another chemical that went up with occupancy is interesting. This is BDE47. It's a flame retardant that was actually phased out over 10 years prior to our sampling. So this is a kind of a story in, even if you phase out a chemical, it doesn't just immediately disappear. In fact, what we think is happening here is it's this flame retardant, which had been phased out in 2005, is being introduced as people bring in old furniture that used that flame retardant, well over 10 years ago. So we can measure these chemicals in our homes. They're in our house dust. They're in our air. We also know that these chemicals are in the products. This is actually kind of the story and the way that we went about our investigation. Right? The Cape Cod Household Exposure Study, I should say, started with us asking just, are these chemicals in our homes? Then we said, oh, we presume that they're coming from products. But nobody had actually done any testing, or at least published it in the peer-reviewed literature to show that these chemicals are in fact coming from products that we use every day. So we did just that. We were the first to publish in the peer-reviewed literature a product testing study where we sent over 200 commonly used products. So these are things like cleaning products, things like hand soaps, lotions, cosmetics, and hair products. Sent those off to the lab and had them analyzed for a broad range of chemicals, including EDCs and asthma-related chemicals. So here we're seeing our phthalates coming back, our parabens, BPA that I've mentioned before. And you can see here that these chemicals, these EDCs and asthma-associated chemicals that we are measuring in our homes are found in the products that we use every day. It's kind of not necessarily surprising, but I want to show or kind of reinforce the idea here is that these chemicals are found in lots of different products, And there's many different chemicals in each product. So we're quickly adding up in our exposures if you're thinking about in terms of product use, right? So, right, we don't use one product at a time. We might use a cleaner. We might also, wash our hands several times a day with an antibacterial soap, and then we apply our hand lotions, apply cosmetics, and style our hair. All of this means that we're adding up our exposures to these important chemicals, things like phthalates, things like parabens. And so this was really kind of started a really important investigation that we've kind of continued is looking at and testing products specifically for these chemicals of concern. So these chemicals are in our homes. We know that they're coming from the products that we use there every day. And these chemicals are also in our bodies. This is results from the kind of a national biomonitoring program from CDC. It's called the National Health and Nutrition Examination Survey, or NHANES. And what I'm showing here are a bunch of individual phthalate metabolites. So these are, phthalate we might be exposed to through the products that we use, or maybe from the building materials. It gets into our body. Our body tries to process it and get rid of it, try to metabolize it. And it excretes these chemicals in our urine. And so this data is coming from urine samples collected from children less than 12 years old. And we can see here that for many of the phthalates, and these top phthalates, the MECPP, MEHHOP, and MEOHP, all of those are phthalates that are found in vinyl products. And so we can see that these vinyl phthalates are getting into our bodies. That second one is MEP. That is associated with fragrances, and nearly every single child in the US has this chemical inside of their body. Now, we are not, though, all exposed equally to this. So I take that same data set and I if I look at it by race ethnicity, you can see here that non-Hispanic Black children tend to have much higher levels. In this case, what I'm showing are results for MEP, that fragrance-related phthalate, in their bodies. And so this is another way that we start a kind of an investigation to try to understand why. What is going on that could be driving up these exposures among particular groups? And so we start looking in the homes, we start asking questions about product use and things like that. I want to shift and talk a little bit, instead of broadly, but a little bit more specifically about a study that we are conducting in Rochester, New York, as a way to try to understand a little bit more about what are some of the influential factors inside of homes that could be contributing to our exposure to these important chemicals. So this is work that we do in close collaboration with the University of Rochester, where we are going into homes in Rochester, homes that are enrolled in their lead hazard control program. So what that means is that they have a child under the age of 6 who spends a significant amount of time in the house. They meet certain income, low income requirements, and there's a lead hazard in the house, which is basically any home built before 1978. And so we're going into these homes and looking at what are the levels of important SVOCs, so those are the consumer product chemicals I've been talking about, in dust before anything happens. And then we follow these homes as they go through what's called lead hazard control. And over on the right there, you can see a photo of somebody actually, they're reinstalling a window. So this lead hazard control program is actually a program that's administered by the city, where homeowners can get a grant to renovate their house to manage or deal with lead hazards inside their home. A lot of these lead hazards are found in things like windows. They can be found in flooring, baseboards. And so these this program is meant to help reduce those hazards through major home renovations. So we follow these homes through the renovations, and then measure their levels of these consumer product chemicals immediately after, and then 4 months after. In addition to measuring these things like phthalates and flame retardants, we're also measuring lead to see how effective the program is, and also things like allergens. So things like that might be indicators, say, of a rodent infestation or a cockroach infestation. Just to make this even more complicated, we also are running this as an intervention study where half of the homes are receiving what we call a healthy homes kit. And we're also doing a walkthrough in the house to help them learn about some of the potential exposure sources inside the house. So we talk to them about their ventilation. We talk to them about how they store certain chemicals inside their home. We talked with them about any pest problems that they might have and how to manage them. And so we've split the folks up into equal groups and kind of follow them over the course of the study to try to understand, are those people that are receiving these resident education, are they actually having a greater improvement in the end compared to those who weren't receiving that education. So I'm excited to share some very preliminary findings from this. First, I'm going to start out with the really great news, is that the lead hazard control program is working. That's great. HUD is investing millions and millions of dollars in these programs across the country. It has been demonstrated before. They are highly effective at reducing lead levels inside of homes, in these high-risk homes. So what I'm showing here on the left is the median concentration of lead measured on floor wipes at the beginning versus the end of the program, and you can see that those levels go down by at least 4 times inside of homes. So that's the really great news. What's interesting though is that while most, if you look kind of 4 months out after all this work is completed, many homes would are considered to be lead-free at that point, but some homes still have lead inside of them. And that is really something that we're trying to address with occupant education or resident education. In addition to lead being in your home because of historically because of lead paint, lead can also be trapped inside of homes. It can blow inside of homes because it can be contaminated soil outside. It can come in on your shoes. So this is really about the fact that there could be other ways that lead could be introduced into people's homes, and that we need to kind of continue with our what we call lead safe practices inside of homes. Remove your shoes when you walk inside the door. Do wet cleaning at least once a week inside the house to wipe down surfaces to reduce lead dust levels and so forth. What else are we finding inside of these homes? Well, we're finding that the mouse allergens are quite common. This is Rochester, and so right, in any colder climate, we often have mice who try to come into the house especially during the winter months. There is a seasonal pattern to that, allergens that we are seeing. We did not see cockroach allergens as often. Our method wasn't that sensitive, but I would also say that I don't think cockroaches are as big of a problem, say, in these homes in Rochester, New York, as they are in a more urban area. But the good news is that we found that folks who vacuumed at least once a week had significantly lower levels of mouse allergens. Mouse allergens are important because they can indicate whether or not there's a mouse infestation, but folks who have respiratory concerns, asthma, might be particularly sensitive to these allergens. And so it's important, especially for folks with asthma, that they will try to control the mouse allergen levels inside their home. So vacuuming at least once a week, particularly with a HEPA filter, so that's a high efficiency particulate filter that will help to significantly reduce the levels of these allergens inside homes. We're also finding, we looked for at least 16 different pesticides, and what's really interesting is that we're finding several banned pesticides inside of these homes. This is not unique to Rochester. In fact, in many of the studies that I've done, whether it be on college campuses or on Cape Cod, right, we find DDT, which was banned back in 1972, in these homes. These chemicals are highly persistent and remain in the homes probably for decades to come, unfortunately. So we can see this this photo on the right is a photo from our study Rock Home, where you can see that some folks were using spray pesticides and other things inside the house. So a lot of my research has been focusing on characterizing exposures and then trying to understand sources. And I couple that with efforts to try to understand what are the most effective approaches for limiting our exposure to these unwanted chemicals inside of our homes. And I would say that has to happen on multiple levels. We cannot say, put this all on the resident to try to control their indoor space. Instead, we need to work at the consumer level, so individual choices. We can also work at the institutional level, the manufacturing level or retailer level, things like restricted substances lists. So that's when major retailers come out with their top 10 chemicals that are banned in products that they sell, or maybe even through regulatory mechanisms. All of these approaches need to be part of a comprehensive approach to limiting our exposures. But I'll walk through a couple of ways that we've tried to target some of these, have a kind of a targeted approach. The first is actually in the fact that Silent Spring has been a pioneer in developing effective and ethical methods for sharing our research results with study participants. And we did this way back in the Green Housing Study. That's the study of subsidized housing in Boston, Cincinnati, and New Orleans. And we do it in dozens and dozens of other studies that we have conducted. We're actually just gearing up to do report back in the Rock Home study. And what do these reports typically include? Well, they include things like, well, what are the chemicals? How do they get into your home? And what are some of the top tips that you can do to try to reduce your exposures? And when we talk to folks, in this case, the Green Housing Study, we talked to participants. They demonstrated ways in which they're using these results to change things, to make changes, right? It could be make changes at the personal level, right? So after I learned from this research that products with fragrances can increase the chemical concentration in my house, I've decreased the use of these products with fragrances. That's important. All of these houses in the Green Housing Study had children with asthma. So that's really important, that kind of self-reflection about the products that they use. People are also using it to talk to their doctors and to actually at the kind of the community level or to promote policy changes. So learning about the levels of your home is one way that can spur action to try to limit exposures. Another great resource is what is a free app that we've developed called Detox Me. This app has nearly 300 research-backed tips. So we've been doing this research studies for decades, and every single time we develop kind of the top 5 tips that you can do based on our research, right? And so we finally decided, well, let's pull all that together so folks can have all of those tips, all of those research-backed tips together. And we pull them together in this free app that's available in both English and Spanish. I encourage you to check it out. It's to help you make more informed decisions about your behaviors inside of your home and the products that you use and the food that you eat. And it has tips that are not necessarily guided at particular products, but more about behaviors or lifestyle choices. Another way that we have demonstrated the effectiveness of individual or personal choices on exposure levels is in a study that we conducted that we call Detox Me Action Kit. This is a crowdsourced biomonitoring study that we conducted, and actually it shut down for the pandemic, but it was crowdsourced, and that anybody living in the contiguous United States could enroll in this study to have their urine tested for common household product chemicals, things like parabens, things like BPA, things like triclosan. And so what's really great here is that we launched this study hoping that we get about 100 people to enroll, and we had 750 people from across the country enroll in this study. And what are we learning? Well, we learned that people are exposed to multiple chemicals. This is not a surprise, but we could see it in our study here. So out of the 10 chemicals that we looked for, most people had 7 of them. Note here, there's nobody who was fully able to avoid any of these chemicals because of their ubiquitousness. We also learned that while product use increases exposure, so while you use more products, that's what's happening on the bottom axes there. So you're increasing your product use, your exposure, your levels that we can measure of parabens in your bodies increases. But they increase differently if you are what we call a non-avoider versus an avoider. An avoider is somebody who reads their product ingredients labels. So if you are able to, if you read your product ingredient labels, you can significantly reduce your exposure to things like parabens. That's great. It means label reading can be an effective way to try to limit exposures. Notice though that the exposures do not fully go away amongst the avoiders. It helps, but it's just kind of more indication that actions at multiple levels. Informed choices can only get, informed personal choices can only get you so far. We need other actions at multiple levels, at the institutional, the manufacturing level, and the regulatory level to help us reduce our exposure to parabens. We also learned from this crowdsourced biomonitoring study that personal behaviors influence exposures, but also the behaviors of others inside of your home. Or just kind of common practices inside of the home. So what we did is that we had multiple people in this study who there were multiple enrollees in a household. So we were able to look at the correlation across the people who were living in the same household and kind of assign or attribute what are the exposures because of what you do personally. So things like parabens, it's mostly what you do, it's your personal choices. But things like UV filters, it can be a bit about what other people are doing inside the house. So that's BP3. And then of course, the shared home environment can be really important. That's things like the materials inside of our home, right? It's going to influence anybody living inside the house or the drinking water. And so this is another way of, again, trying to pull apart where are these chemicals exposures coming from so we can start developing effective strategies. And another study, now we're moving away from that biomonitoring study, but in another study, which we call the couch swap study, we were particularly interested in, it has long been kind of presumed that the couch is a significant source of flame retardants inside the house. That's because flame retardants were added to furnishings like couches to meet certain flammability standards, which had been shown to be actually ineffective. And so back in 2013, there was a change to the regulation of the flammability standards, which meant that we could now buy couches without added flame retardants in them. And so we enrolled folks who swapped out their couches, either the entire couch or they swapped out the foam inside of their couch with things that are with couches or foam that do not have flame retardants in them. And what I'm showing here is the percent change in dust concentration of important flame retardant chemicals before and after this couch swap. So we saw significant reductions in BDE47. I talked about that one before in the move-in study. That's that legacy flame retardant that had been phased out back in 2005. But also TDCIPP, that's our carcinogen again. We can substantially reduce exposures in dust or levels in dust by swapping out the major source of it, our couches or our furniture. So that's great news. So the next time that you go out and you buy a couch, make sure that you are looking for a tag that says no added flame retardants on it. Another effective strategy that we've found to limit exposure to phthalates and also PFAS is actually using air filters. This is actually, so we're going away from just the personal choices, but up to more the institutional level here. This is a study that I did in collaboration with Joe Braun at Brown University, where these, what are called Corsi-Rosenthal boxes, these are air filters, kind of do-it-yourself air filters that were very popular during COVID. Brown University was putting them in their classrooms, and so to reduce COVID transmission. So we wanted to ask, well, if you put these into to classrooms, is it affecting other things in the air inside the classrooms? And we found that, in fact, phthalate levels, so of 5 phthalates and 6 PFAS, the levels, the indoor air concentrations of those phthalates and PFAS significantly declined when we added these filters inside classrooms. This is a great co-benefit, right? This means that by putting these air filters inside of classrooms, not only are we reducing potential virus transmission, but it's also improving the air quality and reducing our exposure to these important chemicals. So as we're moving out again, now we're at kind of the regulatory level. I've mentioned flame retardants and the importance of flammability standards and the fact that flame retardants are used in some furnishings inside of homes. This is actually work that is looking at flame retardant levels in 2 kinds of college campuses. On the right is a college in the orange there. It's a college campuses that adhere to a very strict flammability standard called TB 133. On the left is a less stringent flammability standard that requires fewer flame retardant chemicals to be added to meet it. This is dust actually coming from college dorm rooms. So yes, we went into college dorm rooms and vacuumed them. And actually it was like in April. So they had not been vacuumed in probably about 9 months. And so what are we finding? Well, we found that with the more stringent flammability standard leads to higher exposure, higher levels of flame retardants inside of dust. And so flammability standards matter. These regulations that were put on the books back in the 1970s, presumably because of a great public health benefit, were leading to exposure to chemicals linked to cancer. And these flame retardant chemicals have shown to be actually ineffective in how they were applied to meet these standards. Now, here's the really good news. Both of these standards, flammability standards, are no longer. And in fact, we can still meet certain flammability standards, but without added flame retardants, which is really great news here. And so even regulatory shifts or shifts at the regulatory levels, in this case, flammability standards, can have a profound impact on the levels of these important chemicals inside of our homes or in our living spaces. So I hope I've showed you that these chemicals are ubiquitous. These endocrine disrupting chemicals are ubiquitous in our everyday lives. They're in our homes, they're in our bodies, they're in the products that we're using every day, and that we've started to try to identify and share with folks effective strategies to try to limit exposures. This work is, of course, kind of a compilation of my 17 years in Silent Spring, and so it's not done in isolation here. And also draw your attention to checking out our app. This is actually a tip. These are magnets that we typically have that are coming. It's just kind of pulling out the top 10 healthy homes tips from the Detox Me app. And you can get all of these tips if you go to our website. I encourage you to do that. And with that, I'm all done, but I would love to take questions if there are any.
Dr. Dodson, thank you so much for that really information dense webinar. I mean, there's so many aspects to consider because we not only have to be concerned about our personal choices within our home, but also I was thinking about the dormitories and how when we send our children out, right, they're living now in a new environment. And so what are the concerns within that environment? I want to invite any of our listeners who might have some questions to use the question feature in your GoToWebinar menu, and I'll be monitoring that. But to start us off, you were mentioning some specific chemicals that have been banned or phased out years ago, and they're still being found in homes. Particularly, you mentioned the hand soap, you talked about old furniture. Why is it that these harmful chemicals that have already been recognized, that have been banned or considered for phase out, still persisting in our environment?
Yeah, no, I think that's really important. I think it's, we talk about it as like turning off the tap. Just because we ban a chemical does not mean it just goes away magically, right? We are finding DDT in homes 50 years after it's been banned. And so the question is kind of why? Well, I think one of the reasons is if we think about our homes, they're a very protected environment, right? We do a lot to make sure we don't have wind, rain inside of our house. So it's really hard for chemicals to degrade. In fact, when we often regulate chemicals, we're regulating them because of what we understand about how long they'll last in the outdoor environment. But the indoor environment, it's even longer, right? So DDT, yes, we can still measure that actually in the outdoor environment, despite being banned 50 years ago, but it's much more common indoors now because it's just such a protected place, right? And we see this as kind of is really a call to action. DDT, we've dealt with it, it's been banned, which is good news. But there are chemicals like DDT that are highly persistent, things like PFAS. PFAS are also going to be around in our lives for a very long time to come. And so in some of our writing more recently, particularly around PFAS, we've given that the DDT example as it's really important about the choices that we're making today, because it's not like we can just turn it off if we've changed our mind. This will have an impact decades to come in our homes, in our spaces that we inhabit. So we need to be very mindful about the persistence of these chemicals as we're bringing them into the indoor environment.
So you brought up PFAS, and we've had several of your colleagues from Silent Spring Institute present to us about PFAS. And it's particularly concerning because it is in our drinking water. And so, I know that I can be exposed through drinking water. Are they a concern in my home as well? Are there other products I should be thinking about for other sources of PFAS exposure?
Yeah, so right, as you said, a lot of the research and our understanding of PFAS has been focused on drinking water, which is very important. But we're just beginning to learn about all the other potential sources of PFAS in our everyday lives. So yeah, my colleague, Dr. Shader at Silent Spring has done a lot of work. She's been looking at textiles. She's been looking at food packaging material that can contain PFAS. More recently, she and I have a study that we're looking at PFAS levels inside of homes. So we've gone inside of homes in Hyannis and air and measured dust and indoor air for PFAS, because we know that PFAS can be added to different furnishings inside of homes. They can be added to carpets. They can be added to furniture if you want that stain resistant furniture. They can be found in our kitchen and in the non-stick ware in our kitchen. And so there are all these kind of other ways that we could be exposed to PFAS that are actually kind of avoidable, right? That we could opt out of, say, when you're asked whether or not you want that stain treatment on your brand new couch, opt out. Decide not to spray that stain resistant or waterproofing spray onto your clothing. And so there are steps that we can do to try to limit our exposures, because we know these PFAS are not just coming in from drinking water, but we're exposed to the food we eat, but also in the products that we're using inside of our homes.
We have had someone submit a question, which I think speaks very much to what you were just talking about, which was this individual works for an architectural firm, and they're wondering, what insight can you provide regarding, and where should they start to prioritize their efforts as architects to providing, healthier options to the folks that they're working with in new construction?
Yeah, that's a great question. And I do think that there are resources out there. In fact, our Silent Springs board of directors, on our board of directors, we have an architect who she and I actually, with several others, wrote a piece for the scientific literature around how exposure scientists and architects should get together and share resources and have conversations about the impact of some of the choices of the specifications that are done by architects in the indoor spaces. So I think that there are ways to, there are either these tools out there, these dashboards that are trying to identify materials, building materials that do not have these chemicals of concern, like PFAS, things like that. I do know in conversations that we've had, there are also just kind of different design choices to make, right? Like maybe we don't need that white carpet that we need to apply a stain resistant treatment to. And kind of just making different design choices, using different flooring materials, using darker colors, things like that, that are all these kind of different options. And ways that you could be clever. And it's a very important time to consider these options, consider our indoor exposures when we, in new construction or in renovation, when we are specifying the materials that we're building our homes with.
And is it helpful if I've had a renovation in my home to, air it out, to open up the windows, to get in, obviously dusting and cleaning? I feel like I should go home and dust right now after your presentation today. But if I've had a renovation, there usually is some settling that has to happen. Is it beneficial for me to go in and think about cleaning and opening it up and getting it aerated?
Yeah, so I mean, it's important to consider. Ventilation will help for some of these chemicals, the more volatile ones. So I showed that in the move-in study. There were a couple of chemicals, xylene, toluene, things like that. Those are very volatile. With increased ventilation, you can significantly reduce the levels of those chemicals. Now, some of these things like PFAS, well, those are what I kind of consider heavy materials or heavy chemicals. Those are not necessarily you're not going to be able to draw down the levels significantly with ventilation alone. So we need to couple that with things like cleaning. So cleaning practices, healthy cleaning practices. So I'm not talking about getting that specialty cleaner for every single thing inside of your house, but things like vacuuming. Vacuuming frequently, I showed it significantly reduces mouse allergen levels. It has been demonstrated to reduce lead, flame retardants, all sorts of other PFAS inside of the house by vacuuming regularly. And so there are ways with safe cleaning habits that you can significantly reduce the exposures. But I do think it kind of goes back to that's what you should do if you've had the renovation. Now, if you're coming up to a renovation, back to that question from the architect, we should be a little bit more mindful about what are the actual materials that we're using, avoiding the stain resistant treatments. The other thing that we were seeing actually a lot in Rochester too, that folks are opting for, that I want to kind of flag for folks, is avoiding what's very popular is resilient flooring, like luxury vinyl flooring. It's really appealing. It lasts forever, but it's got a lot of phthalates in it. And we can see that inside of homes. So it seems like a great option. It's usually economical, but unfortunately, it comes with some phthalates and increasing phthalate levels inside of some homes that have that. So
interesting. So what are the projects that EPA will require industrial chemicals be proven safe before they are issued for public use?
So EPA is not necessarily doing that at all, right? So here in the United States, our chemical regulations are kind of the opposite of that, where you do not have to prove a chemical safe before it is added to products. Europe does it the other way. So we know it's possible. We know it's possible to try to demonstrate safety before their use. And so we need to kind of keep pushing EPA to be more comprehensive in their evaluation of chemicals before they're allowing their use. There are some actions under TSCA, the Toxic Substance Control Act, and other ways that will help with certain chemicals, but there are tens of thousands of chemicals in US commerce. So that's only going to work for a handful of chemicals. So instead, yes, I mean, unfortunately, EPA right now has got it completely backwards. And we need to be knowledgeable of that and acknowledge the fact that just because a product is on the shelf does not necessarily mean it is free of harmful chemicals.
And we have our last question here. What are the issues from vinyl shower curtains?
Oh yeah, so in our product testing work, we included vinyl shower curtains, and we found that about a quarter of the curtain by weight, so it was like 28% by weight, was a phthalate, DHP. Now DHP is probably the most potent phthalate. And so it is certainly, that is kind of one of the top tips I always give, is just avoid vinyl shower curtains, and vinyl flooring, toys, things like that inside of your home. There are some great other options, things like nylon showers, curtains. So it's not like I'm asking you to totally change everything. It's just reaching for the nylon curtain instead of the vinyl curtain, because that is just one really easy kind of low-hanging fruit to try to reduce your exposures.
Thank you so much, Dr. Dodson. On behalf of myself, the MBCC board, and Cheryl Asimo, MBCC's executive director, I want to thank you for this very informative discussion today. And I want to thank all of our many listeners for joining us. For those interested, the recording of this webinar will be made available later today on the MBCC website at mbcc.org. And if you would like to further support our mission of preventing environmental causes of breast cancer, please consider making a donation by visiting mbcc.org/donate. I appreciate your consideration. Have a good afternoon. Thank you so much, Dr. Dodson.
Thank you.